Hello students, welcome you to this session. Really, I am very happy to see you through this video. We have planned to conduct number of live classes to cover some of the very important topics and some of the topics you may think it is difficult. இதெல்லாம் கொஞ்சம் கஷ்டமா இருக்குல்ல அப்படின்னு நீங்க என்னெல்லாம் நினைக்கிறீங்களோ அந்த டாபிக் எல்லாம் we are going to cover through this video. If you ask me which one is tough in mathematics, I say nothing is tough. Everything is easy only. But the way how we approach. Listen, in today's class, we are going to study one of the very important area, calculus. That's one of the very, very important one. For higher classes, very important one. In the lower classes, see, multiplication. While studying multiplication table, you would have studied the very lower class, right? But at that time, you don't know why we are studying. But when you come for 10th standard and all, when you do some mensuration sums, volume of a sphere, 4 by 3 pi r cube, you study there. But when you do the calculation, if you make mistakes in multiplication, totally you'll be losing mark, right? Same way, some of the basic things for higher education, higher classes, after 10th standard, you need calculus, trigonometry. All these things are very, very important thing. So calculus, mainly there are two parts, differentiation and integration. Don't think it is only for math students. It is for science students also. In physics, we are using a lot of calculus, differentiation, integration we are using. Its application, don't think it's very high level, only navigation and other things we have its application. No, even in real life we have its applications. So everything we'll discuss in the classes. So in today's class, we are going to start differentiation. Right from the basics, I'm going to start today. Suppose you may say, sir, I don't know anything in differentiation, don't worry. Today only I'm going to start right from the basics. Then in the next class, we'll continue. Then in the third class, we'll learn something advanced, so which will be useful for even for JEE exam. So such a way I have planned. Then after that, we'll be discussing integral calculus, trigonometry, and what are the topics you find difficult, you can tell us. We are here to help you. So now we discuss differentiation, differential calculus. So here, differentiation and integration. Today we are going to see differentiation. Differentiation, it is a process of finding derivative, right? Addition, subtraction, it's a process, right? Same way, differentiation is a process of finding derivative. What is derivative? So derivative, today we are going to discuss derivative as a rate of change. Derivative is a rate of change. By that what we mean? Suppose I am taking an equation, say y equal to 2x plus 3. There are two variables, x and y. Suppose I put x equal to 0. When I put x equal to 0, what is y value? When I put x is equal to 0, what is y value? It is 3, right? When I put x equal to 1, what is y value? 2 into 1, 2 plus 3, it is 5, right? When I put x equal to 2, what is y value? 2 2s are 4, 4 3s are, 4 plus 3 is 7. So you can notice when x is changing, x change பண்ணும்போது எதுல change வருது? Change in y also, right? When you change x, it affects y, right? So the rate, how much it affects, எவ்வளவு அது affect ஆகுது, that is called the rate of change. Rate of change in y with respect to x. When you change x, there is some change in y, right? That we denote it as dy by dx. Rate of change in y with respect to x. Suppose I am giving, say y is equal to 7. Y equal to 7. See, x and y. I am taking x equal 0. What is y value? Y equal to 7. There is no x. When I put x equal to 1, what is y value? 7 only, because there is no x. If there is some x value, we substitute. When I put x equal to 5, y is 7 only. So what is the rate of change? There is no change at all. If you change x, there is no change in y. So in that case, rate of change dy by dx equal to 0. So we say rate of change or the derivative of a constant is what? 0. Derivative of a constant is 0. Those who are preparing for NEET examination, suppose some of you may be studying pure science, right? So up to 10th standard only you studied. You may be afraid. So if you take your physics book, there is a lot of differentiation, integration will be there. So if you attend these classes, definitely I'll be helping you. What are the differentiation you need to clear the sums which comes for NEET examination? Okay, so it will be useful for you also. Those who are studying business maths, general maths, it will be useful. Okay. So now listen here. So I said a lot of applications are there. Even in day-to-day life, suppose you are running a business. You want to maximize your profit or you want to minimize the cost. You can use differentiation. Very simple differentiation, you can use that. To find slope, you can find differentiation, and a lot of applications are there. And for physics, listen, I said differentiation is rate of change. Rate of change. That we can call it as what? Derivative. Derivative. You know what is velocity? What is velocity, you know, right? So displacement I'm taking. Displacement, I'm taking it as S. It is a function of t. Displacement is a function of t. You know what is velocity? If I ask velocity, immediately you say, right? Rate of change of displacement, right? Velocity is equal to rate of change of displacement. Rate of change of displacement. I said rate of change can be replaced by what? Derivative. So you can say it is the derivative d by dt because it is a function of t, right? D by dt of s, or you can say ds by dt. If you differentiate displacement, you will get what? Velocity. Then you know what is acceleration? Acceleration is rate of change. Rate of change of velocity. Rate of change of velocity is acceleration. You know, rate of change means it is what? Derivative, right? So acceleration is derivative of velocity, dv by dt. So remember, when the displacement is given, if we differentiate one time, you will get velocity. If we differentiate once again, you will get acceleration. It's inverse operation. Differentiation for addition is subtraction, for multiplication, division. Like that for differentiation, the inverse operation is integration. So displacement to velocity, you differentiate. Velocity to acceleration, you differentiate. Suppose acceleration is given. You want to go in this direction, you want to get velocity, you have to integrate. Then velocity to displacement, you have to integrate. Okay, that we'll study later. Then I said there are two types of variables, independent variable and dependent variable. So suppose y is a function of x. When y is a function of x, you can find dy by dx. You can find dy by dx because y is a function of x. Suppose y is a function of x. Here you can calculate. How? We'll see that. Suppose y is a function of x. Suppose I'm asking you find dy by dt. Then you should say the answer is what? 0, because there is no t at all. If you change the value of t, it is no way it is going to affect what? Y. Because y la only x, there is no t. So if you change t value, it is not going to affect. Okay. So with this simple introduction, so let me explain some of the formula. So before that, derivative, how to denote. So derivative of, suppose y equal to f of x is a function. Y equal to f of x is a function. The derivative, we denote it as dy by dx. That is one way, dy by dx. You can denote it as y dash, or you can denote it as y1, or you can write y equal to f of x. So the derivative can be written as f dash x. So these are some of the symbols, the way of writing. Okay. And some formula you have to study. To learn the entire differentiation, you need around 25 formula. Only 25 only, right? If you're thorough with that, you can answer any question. So today I'm not going to discuss everything. First I'm going to discuss few formula, then based on that we are going to do some sums. Okay, after being thorough with that, we go for the next formula. Okay, now please listen. Already we discussed one formula, the derivative of constant, right? Derivative of constant is 0, right? Okay, now y and dy by dx. Take the first formula, constant. If I take constant, already you know the derivative of constant is what? 0. And the most important and the formula where we use the more number of times, adhigama use pannakodiya or formula irukudhu, that is x raised to n. The derivative of x raised to n is n into x raised to n minus 1. X raised to n, remember x is a variable, n is a constant, x raised to 5, x raised to 3, something like that. X raised to n, look at the derivative, x raised to n derivative, n goes front, and the power front la x raised to n is n into x raised to n minus 1, power you reduce 1. Okay, just few formula I'm going to give, try to learn now itself, then immediately after that we are going to do sums. Then I will give you some sums also to do. Okay, so first one, constant derivative 0, x raised to n derivative n into x raised to n minus 1. Then x derivative 1, take it as a formula, but you can use the same formula. X means x raised to 1, right? X raised to 1. If you apply the same formula, 1 goes front, x raised to reduce 1. Any number raised to 0 is 1, right? 1 into 1 is 1. Save it and don't waste time. X, the derivative is what? 1. Then e raised to x. E raised to x derivative, e raised to x itself. A raised to x derivative, a raised to x log a. So now you may have a doubt. E raised to x is e raised to x, then a raised to x, why it is a raised to x log a? Please listen, this is the main formula. A raised to x derivative a raised to x log a. Then what's the derivative of e raised to x? It should be e raised to x log e, right? A raised to x derivative a raised to x log a. So e raised to x derivative must be e raised to x log e. But you know log e value is 1. Log e is 1, right? So e raised to x into 1, so that is why e raised to x derivative is what? E raised to x itself. But remember this, a raised to x derivative, a raised to x into log a. That is the basic formula. From that only you are getting that e raised to x. That's a particular case. E raised to x into log e is 1. Okay, so that is another formula. Then the next one is very important one, log x. This is for natural log. Natural log means the base must be e. This is natural log. Logarithm, there are two types of logarithm. One is natural logarithm, another one is common logarithm. For common logarithm, base is 10. Log base 10, this is common logarithm. So this is natural logarithm, or you can write ln, L-N, right? Ln x. It is natural logarithm, that is meaning the base is what? E. Log x to the base e. Its derivative only log x. Log x to the base e, that is the natural logarithm. Its derivative is what? 1 by x. Then what is the derivative of log x to the base 10? We will discuss later. Okay, I'll help you that one. Okay, so this is another formula. So now around 6 formula I given. So based on that, I think we'll try few questions and I'll try to give few more. 1 by x derivative. 1 by x derivative minus 1 by x square. 1 by x square derivative minus 2 by x cube. And the last one, root x derivative 1 by 2 root x. All these you take it as formula. But I'll tell you, all this you can prove it very easily using that just one formula, x raised to n. What's the derivative of x raised to n? X raised to n derivative, n into x raised to n minus 1. The power n comes front, then x raised to reduce 1, right? Using that you can derive all these things. Because 1 by x means x raised to minus 1, right? I'll give the proof of that also. So look at this once again. Constant derivative 0, right? Constant, the derivative 0. X raised to n derivative, n into x raised to n minus 1. X derivative 1. E raised to x derivative, e raised to x. A raised to x derivative, a raised to x log a. Log x, that is natural logarithm. Log x to the base e, it is 1 by x. 1 by x derivative minus 1 by x square. 1 by x square derivative minus 2 by x cube. Root x derivative 1 by 2 root x. Most of the things don't, actually if you see, I should say there are only 4 formula. All of the things are we applying the formula only here. So using this one I am telling around 25 formula. In that 25 formula now itself you study 9 of them, right? Listen, now let us see few simple sums. After that I'll explain this 7, 8, 9 and all how we got that one. Okay. Now let us discuss few simple sums. So differentiate the following. Differentiate the following. I'm going to start with very basic things. Some of the students, those who are attending today's class, you may know all these things, but anyhow, so gradually you grow. So this is the main problem, students. Please listen here. Why you find math tough, Sometimes if you study systematically, there is no problem at all. That's what I said, how you approach. Sometimes what happens, we won't study properly. We won't study the basics and all. The exam நெருங்கும்போது ஒரு ஸ்பீடு வரும்ல. உடனே என்ன செய்வோம்? What are the important sums? What are the difficult sums? What are the repeated questions we see? That may be in the 4th exercise or 5th exercise. We take that sum and try to solve. You definitely will find difficult. Differentiation like that only. So the basics, suppose first 1 or 2 exercise, they may not ask any question for the examination. But without knowing this, you cannot do that one. So learn from the beginning. Remaining are very easy. Mathematics don't learn for maths at all. So not maths or learn for marks. மார்க்குக்காக மட்டும் படிக்கக்கூடாது. That is not education, right? We should learn, equip yourself. Mark will come, அது ஆட்டோமேட்டிக்காக வந்துடும். So that is how you have to prepare, especially this topic, differentiation, integration. You should strong foundation. அப்பதான் உனக்கு எந்த சம் வந்தாலும் you can do that. Don't depend. So I'm not going to take any book sum and all. Just I'm going to teach you the concepts. எந்த சம் வந்தாலும் நீங்க செய்யலாம். Already those students, those who prepared, those who study differentiation, you may have a doubt, sir, I know all these formula and all, but when to use which method, I have doubt. So when to use product rule, when to use parametric equation, when to use logarithm. So everything will be clear here. Okay, so we go systematically. Look at the first question. Differentiate the following. The first question say y equal to x raised to 5. Very simple question. This is of which type? X raised to n, right? So dy by dx is equal to, the 5 comes front, 5 into x raised to reduce 1 power. It become what? 4, right? Suppose I am taking a question y equal to x raised to 8. What's your answer? Dy by dx. When you differentiate, you write dy by dx equal to, the 8 comes front, 8 into x raised to 7, right? 8 into x raised to 7. Okay, try this question, y equal to x raised to minus 4. Try, students. See what answer you are getting. I think you may have book, pen and all with you, right? So try to work it out. Same method. This is of the type x raised to n only, no? Yes. Dy by dx is, the minus 4 comes front, right? Minus 4, x raised to reduce 1 power. I think I know some of you would have written minus 3, right? If you reduce 1, see minus 4 is there. If you reduce 1, what happens? Minus 4 minus 1, it is what? Minus 5. If you want, you can bring it down finally. Minus 4 by x raised to 5. Okay, you can write like that. Then another question, question number 4. See, y equal to 5 plus x raised to 6. Please listen here. Here there are two terms, right? There are two terms. Y equal to 5 plus x raised to 6. So differentiate both the terms separately. So dy by dx equal to, first one is 5. 5 is a pure constant, right? Constant derivative 0. Plus x raised to 6. X raised to 6 is like x raised to n. So you have to use 6 into x raised to reduce 1, 6x raised to 5. So your answer is 6x raised to 5, right? This is 5 plus x raised to 6. I'll give another question. Y equal to 5 into x raised to 6. Please listen here. Previous question and this question. Previous question 5 plus x raised to 6. Here y equal to 5x raised to 6. Sometimes even the student, the bright students, after finishing everything, they'll come and ask, sir, y equal to 5x raised to 6. 5 derivative 0. X raised to 6 derivative 6x raised to 5. So the answer is 0. No, it is not 0. It is not two terms. Together it is a single term. If there is minus or plus, if it's separated by plus or minus, then only have different terms, right? 5x raised to 6 is a single term. It is not a pure constant. In the previous one, there are two terms. In between plus is there, no? Two separate terms are there. 5 is the first term is 5. It is a pure constant. So its derivative is 0. But here, 5x raised to 6, together you should see, it is not a single, it is a single term only, just one term. It is not pure constant, so you can't put 0 here. So dy by dx is equal to that 5 you write as it is. X raised to 6 derivative, 6x raised to 5. 6x raised to 5, so your answer is 5, 6 are 30, 30x raised to 5. Okay, so this is how we have to do this. So now I'll give you just one or two questions. Just note down and you try that questions. See, y equal to x cube minus 7x plus 6 and y equal to 3 plus x square. Try to do these questions and you can type your answers in the chat box. Question number 6 is y equal to x cube minus 7x plus 6. Let me see how much you understood. Second one, y equal to 3 plus x square. Yes, come on students. Yes, some of you got it. The sixth one, y equal to x cube minus 7x plus 6. So here your answer dy by dx is x cube derivative 3x square, right? 3x square minus 7 into x derivative 1. So 7 into 1, 7 plus 6 is a constant, the derivative 0. And sum number 7, y equal to 3 plus x square. Very simple answer. Can you type your answers? Y equal to 3 plus x square. Yes? Only two terms are there. 3 plus x square, differentiate separately. First one, dy by dx is 3 is a constant, derivative 0. And good, x square derivative 2x. Very good. Many of you got the answer. Okay, now listen here. Now let's move on to another question. So next level we go. Suppose x raised to 2 by 3. Say y equal to x raised to 2 by 3. Same type only, but some fraction is there, that's all. So you can do this one, same method you can do. So y equal to x raised to 2 by 3. What happens, the 2 by 3 comes front. X raised to reduce 1, 2 by 3 minus 1. Take 3 as LCM. So 2 minus 3. What is 2 minus 3? Minus 1 by 3, right? So this is your answer. If you want the negative power, you can bring it down. 2 by 3, that numerator x raised to minus 1 by 3, you can bring it down. X raised to 1 by 3. X raised to 1 by 3. So same method only. Y equal to x raised to n, right? N into x raised to n minus. While subtracting, you do it carefully. Look, another question. Now I think you can try this question. Y equal to root x. Y equal to root x. That is y equal to, rewrite. Y equal to root x means x raised to half, right? Y equal to x raised to half. Root x means x raised to half. So try to differentiate this one. Same method. X raised to n only, no? So dy by dx is, now please listen, another important thing I want to tell you, you must know when to write dy by dx. See, the question is y equal to root x. I am rewriting. While rewriting, don't write dy by dx, you write y itself. Y equal to x raised to half. Now dy by dx, now we are going to differentiate it. The moment you differentiate, you write dy by dx. X raised to n type. So n into x raised to n minus 1. So that is 1 by 2 into x raised to, you take 2 as LCM, 1 minus 2. 1 minus 2, it is what? Minus 1. So this can be written as 1 by denominator 2, that negative power you bring it down, x raised to half. That is 1 by 2 into x raised to half is same as what? Root x. This only I given as a formula, no? Root x derivative 1 by 2 root x. Root x derivative. This is how we are getting. See, why I am asking you to take it as a formula, when you do a big sum, it will come as a part. So for that at all, you should not waste time, right? If you take it as a formula, so you can write the answer directly. Because it will come quite often. So root x derivative 1 by 2 root x. Same way I given another one, 1 by x, right? So let us try how we are getting y equal to 1 by x. How can you differentiate this one? So you can't differentiate directly, so you rewrite. 1 by x, take it to the numerator, it will become x raised to minus 1. Now this is of the type x raised to n, you can differentiate it, so write dy by dx equal to n into, n is minus 1, n into x raised to n minus 1. So you are getting minus 1 into x raised to minus 2. That is minus 1. That negative power, you bring it down, denominator you write x square. So already you study, right? 1 by x derivative minus 1 by x square. 1 by x derivative minus 1 by x square. Most of the students will study this and all. Root x derivative 1 by 2 root x. Log x derivative 1 by x. 1 by x derivative minus 1 by x square. But I have given one more formula for you. Question number 11. 1 by x square. Most of the students, they won't study. So if you learn this also, you will be the topper, right? You will be the better position. So you can save some more time. So for that you cannot study everything, right? 1 by x raised 7, you cannot mug up everything. So, but at the same time, you must know how to do this. So we rewrite it, y equal to, take it to the numerator, x raised to minus 2. Now we differentiate, dy by dx equal to minus 2 comes front, x raised to reduce 1 power. When the negative power comes, students, you have to be very careful. ரொம்ப careful செய்யணும், இதில் தான் mistake வரும். பவரில் என்ன இருக்குதுங்க, minus 2. You reduce 1, minus 2, minus 1, you will get what? Minus 3. Negative power வரும்போது you bring it down. So, you can write it as minus 2 by x cube. This also I given as a formula, right? 1 by x square derivative minus 2 by x cube. Everything included in that 9 formula. So, main formula what is studied, recall just the formula, constant derivative 0. X raised to n derivative n into x raised to n minus 1. N into x raised to, using that only, all these things we did. Which one? That root x, 1 by x, right? 1 by x, 1 by x square. All these things we did using the same formula. Even x derivative 1, that also, see, now itself 1, 2, 3, 4, 5, 6 formula, right? Then what else you have? A raised to x and log x, right? A raised to x derivative. What is a raised to x derivative? A raised to x log a. Please listen, what's the use of, where we have to use this? Sum number 12. Please listen, y equal to, again I am taking y equal to x raised to 7. You may say it's a very simple one, right? Yes. So dy by dx is x raised to 7 derivative what? This is of which type? X raised to n. So n into x raised to n minus 1, 7 minus 1, 6. But if my question is y equal to, instead of x raised to 7, I am writing 7 raised to x. Can you use that formula? No, this is not of the type x raised to n, so it will be very careful. So two formula, one is x raised to n, there is a formula. A raised to x, there is another formula. X raised to n formula, n into x raised to n minus 1. A raised to x formula, a raised to x log a. But you see the question, both look similar, right? Exponential form, a raised to m type. But see the variable and constant. X raised to n, variable raised to constant. Variable raised to constant, power is a constant. But a raised to x, constant raised to variable. Right? First one is variable raised to constant. That is x raised to n x raised to n minus 1. But the second one is a raised to x. A is a constant, power is the variable. So here this is of the type 7 raised to x. Don't apply x into 7 raised to x minus 1. Don't write that, students. That is wrong, right? So this is type a raised to x. So a raised to x derivative, another, what is a raised to x derivative? A raised to x log a. So dy by dx equal to 7 raised to x derivative, 7 raised to x into log 7. 7 raised to x derivative, another 7 raised to x into log 7. What is the derivative of y equal to 2 raised to x derivative? dy by dx, try to do it of your own. This is type x raised to n, a raised to x. A raised to x type, right? So 2 raised to x derivative, what's 2 raised to x derivative? 2 raised to x log 2. 2 raised to x log 2. Another question I'll give you. Y equal to 5 raised to 12. Differentiate quickly and post your answer in the chat box. Let me see how many of you are doing fast. Y equal to 5 raised to 12. Put your answer, come on fast. So that I can understand whether you are able to understand. Then only I can go to the next level. Yes? Y equal to 5 raised to 12. Even if it is wrong, don't worry. Five raised to 12, is it the answer is 12 into 5 raised to? Yes, yes, yes. Very good, very good. I'm getting a lot of answers. Good. Everything is correct. Very good. So you understood so far, right? So dy by dx is, the derivative is 0 because it is a pure constant. 5 is a constant, 12 is a constant, right? 5 raised to 12, it is a constant. There is no variable at all. So the derivative is equal to 0. Very good, students. So let me continue the next one. Suppose I'm giving the next question. Y equal to 2 by x cube. Next level. Like that one by one you do, just I'll check it, then we'll go further, okay? So y equal to 2 by x cube. Let me see how to differentiate this one. So you have to rewrite it, right? So don't apply quotient rule. Some of you may think, because I didn't teach quotient rule so far, so you won't think that one. The later, after studying everything only, the problems will come, right? Numerator, denominator, you may think we have to go for quotient rule. No. So here 2 is a constant only, no? Okay. So now you rewrite, take it to the numerator. So y equal to 2 into x raised to minus 3. Y equal to 2 into x raised to minus 3. If you differentiate y equal to, please listen, but before doing this, earlier I given a formula y equal to 5 into x raised to 6, something like that, okay? So what is the differentiative dy by dx equal to? It is a single term, so you should not have a doubt 5 derivative 0. No, it is not a separate term, right? 5x square, x raised to 6, together a single term. 5 is not a separate term. So 5 we write as it is, x raised to 6 derivative 6x raised to 5. So if you simplify 30x raised to 5, but now without writing this, you must write the answer directly. So what you do now for that? You just multiply these two. 6 into 5, multiply these two. 6 into 5, 6 5s are what? 30, x raised to reduce 1 power. Suppose y equal to 7x cube. Directly can you say the answer? dy by dx. Multiply these two. 7 3s are 21, x raised to reduce 1 power. Okay, like that you should write. Hope you understood that one. Okay, now listen. So here what answer you can say? Dy by dx is equal to, this is like that only, all together ஒரே term தல single term. So how can you differentiate it? You multiply these two. The ரெண்டே multiply பண்ணா என்ன வரும்? 2 into minus 3. It is what? Minus 6 x raised to reduce 1 power. Negative வரும்போது ரொம்ப கேர்ஃபுல்லாக செய்யுங்க. பிகாஸ் இஃப் a small mistake, totally will be wrong, right? So to very careful, over confidence வரக்கூடாது மேத்ஸில். That's very important. Reduce 1, minus 3, minus 1, you will get minus 4. So your answer is minus 6 by x raised to 4, right? That is question number 16. Hope you understood. Now let us go for question number 17. Listen. I'm giving a question, say y equal to cube root of x. Square root of x we did, no? Same method only. Cube root of x. What do you do? You have to rewrite. Already I said when you rewrite, don't write dy by dx, right? You write y equal to cube root of x means x raised to 1 by 3. Square root means x raised to 1 by 2. Nth root of x, what's the meaning? X raised to 1 by n. So here y equal to x raised to 1 by 3. Now we differentiate dy by dx equal to x raised to n type. See, just one formula we are using here, right? X raised to n derivative n into x raised to n minus 1. So you are getting 1 by 3 x raised to, take 3 as LCM, 1 minus 3 into 1, it is 3. So you are getting 1 by 3 x raised to minus 2 by 3. Negative power, you can bring it down. 1 by 3 into x raised to 2 by 3. Hope you understood this one, right? So this is question number 17. Note down that one. Now question number 18. Y equal to 4th root of x cube. Can you try this one? Y equal to 4th root of x cube. Because all these things you must be thorough. Because after differentiation, you will study application of differentiation, right? The student, those who are in 12th standard, you are going to study application of differentiation, application of integration. Without knowing proper differentiation, you cannot apply that, right? So you must know differentiation thoroughly. Let them be any function, you must know how to do that, okay? Look at this one, y equal to 4th root of x cube. You can write it as, you can write it, rewrite it, right? Please listen here. 4th root means raised to 1 by 4, right? 4th root means raised to 1 by 4. Here x cube. A raised to m, the whole power n, it is a raised to mn. You have to multiply x raised to 3 into 1 by 4, it is 3 by 4. So what I want, you should write this directly. You should not make mistake also at the same time, right? So 4th root means raised to 1 by 4, no? So here x raised to 3 by 4. Then what is 7th root of x raised to 6? Can you write directly now? X raised to 6 by 7. 7th root means 1 by 7, right? So what is then square root of x cube? Tell me what is that? X raised to No number is here. No number means it is what? Square root 2, right? Here 3. So this is x raised to 3 by 2. All these things you should develop. So you can save time. When you go for some competitive exams, the time also very important, right? So x raised to 3 by 4, y equal to x raised to 3 by 4. Now usual method, x raised to n, right? So dy by dx is n into, so 3 by 4 into x raised to 3 by 4 minus 1. So you are getting 3 by 4 x raised to. Take 4 as LCM. 3 minus 4, it is minus 1. Whenever you get a negative power, you bring it down. 3 by 4 into x raised to 1 by 4. So hope you understood all these things. Okay, now I think we can go for the next question. Y equal to x into x square minus 5. Y equal to x into x square minus 5. Can you tell me how to do this one? Some of you may think we have to apply product rule. No. Just expand it. So y equal to multiply x into x square. We are rewriting. So just you write what? Y only. Don't write dy by dx. X into x square, it is x cube. Minus x into 5 is 5x. Just we have expanded. That's all. Now you have to differentiate it, right? Dy by dx is. Now it is like a revision for you, right? X cube. What's the derivative of x cube? 3x square. 3x square minus 5x derivative 5, because x derivative is 1, right? Now question number 20. Suppose the question is y equal to x plus 2 into x minus 3. No need to apply any product rule here. I didn't teach you so far, don't worry about that. So in the next classes I will teach product rule, quotient rule, everything, then you should not get confused. Okay, so listen. Here the method is, you just expand it first, term by term multiplication. Algebra in the lower class you would study, right? X into x, x square. X into minus 3, minus 3x. 2 into x, 2x. 2 into minus 3, minus 3. Simplify the group, the like terms, simplify. We are rewriting only, so keep on writing y. Don't write dy by dx. You must, normally the students make mistakes. Simply, first step itself they put dy by dx. No. So where to you write dy by dx, you know? When you differentiate that moment, at that particular step, you write dy by dx. X square minus 3x minus 2x, it is minus 1x minus 3. So don't run away, it is not at over, it is only we simplified, right? This is differentiate panna poringa. So dy by dx equal to, you can write the answer. X square derivative 2x raised to 1, right? So 2 comes from 2x raised to 1. So x square derivative 2x, that's all. X square derivative 2x minus x derivative 1, 3, constant derivative 0. Okay, so you can do this one. Now another very important thing. Suppose the question is y equal to 2x minus 5. Y equal to 2x minus 5. Listen carefully how to do this one. 2x minus, okay, I will give a denominator also. 2x minus 5 by 3. How can you differentiate this one? Can you split into 2? Yes. A plus B by C. You can split into 2. A by C plus B by C. So you split like that. Don't apply any quotient rule here. So y equal to, we are rewriting 2x by 3 minus 5 by 3. So dy by dx is 2 by 3 is a constant. X derivative 1. Together a single term, it is not pure constant, variable is there, x is there. 2 by 3 write as it is, x derivative 1 minus 5 by 3 is a pure constant, so the derivative is what? 0. So your answer is 2 by 3. Even this sum you can do directly also. Numerator, denominator only 3, no? That 1 by 3 you take outside. 2x derivative 2 minus 5 derivative 0. So the answer is what? 2 by 3. Okay, any one method you can do that. Now question number 22, y equal to 2x square minus 5x plus 6 by x. How can you differentiate this? Sometimes the students, what they do, no? 2x square derivative 4x minus 5x derivative 5, 6 derivative 0 by x derivative 1. No, it's wrong. If there is only numerator, you can do like this, right? Denominator is also there. Quotient rule, no need to apply. So split into 3 terms like previous one, right? So you can rewrite it y equal to 2x square by x minus 5x by x plus 6 by x. We are writing only now, right? Now try to simplify. So again y only, we are not yet differentiated. So 1x get cancelled, so 2x minus x get cancelled, 5 plus 6 by x. I'm not rewriting the last one. If you don't know the derivative of 1 by x, please listen, if you don't know the derivative of 1 by x, you have to rewrite here. The 6 you have to take it to the numerator, x raised to minus 1. Then you have to apply n into x raised to n minus 1, but I asked you to take it as a formula. 1 by x derivative. What is 1 by x derivative? Minus 1 by x square. Even I asked you to learn 1 by x square minus 2 by x cube, because these things will come quite often, okay? So for that purpose, otherwise see here and all you have to waste time, right? So now directly you can write the answer. You know the derivative of 2x, you know the derivative of 5, you know the derivative of 6 by x also. So you can write dy by dx equal to straight away 2x derivative 2, because x derivative 1, minus 5 derivative 0, plus 6 is a constant, don't put 0, 6x together a single term, it is not a pure constant, x is there, right, variable is there, 6 into 1 by x remaining, 1 by x derivative minus 1 by x square. So the final answer is 2, second term 0, leave it, plus into minus is minus 6 by x square. Hope you understood this one, okay. That is sum number 22. Then 23, look here. So far what I taught, are you able to understand? This is one question for you. 2x minus 3 into x minus 2 divided by x square. Just I'll give you a 1 minute time. Just you may have the paper with you. Just try to do that. You don't need to, suppose the answer is big, you cannot type there. Just you try. Even if it is mistake, don't worry. So mathematics only by practice you can do that. Just try to do that. Let me see whether you are approaching the correct way. Yes, here the method is, this is actually I'll give some hint. The combination of this one, question number 20. Look at the question number 20. 2 factors, right? You multiply, right? Okay, combination of this one and this one, 20 and 22. There are 3 terms you split. So I think you got the idea now. First you have to simplify this, right? What do you do? Numerator, you multiply term by term. Multiply term by term, simplify. Then denominator is x square, you split it. And you can do that. Try this quickly. Okay, so y equal to multiply term by term, 2x into x, 2x square. This is the idea you have to get by seeing the question how to do this. Okay, you can do this way. 2x into x, 2x square. Then 2x into minus 2, minus 4x. By this minus 3 you multiply minus 3x. Minus into minus is plus, 3 2s are 6 by x square, right? Next step, again you write y only. We are going to simplify this, right? So see the like terms, 2x square, minus 4x minus 3x, minus 7x, plus 6 by x square. Now it has come to this type, right? This type, yes. Now what do? You split into 3. So again we are going to rewrite only. So keep on writing y only. So y equal to 2x square by x square, split into 3 terms, minus 7x by x square, plus 6 by x square. Now try to cancel. Y equal to, first one x square cancel, only 2. Minus second one, 1x get cancelled, so 7 by x, plus 6 by x square. Next step, you just go through everything. If you know the derivative of all the 3 terms, you differentiate it. Suppose even one term needs some rewriting work. Yada one term நம்ம rewrite பண்ணனும்னா differentiate பண்ணக்கூடாது. அதை rewrite பண்ணிட்டு next step. So differentiate பண்ணும்போது do everything at a time. 2 term differentiate பண்ணி ஒரு term differentiate பண்ணாம rewrite பண்ணி, don't do that. Sometimes students do that. Okay, that's wrong. Because what you write in the left side, y னு எழுதுவீங்களா இல்ல dy by dx எழுதுவியா இல்ல? So when you differentiate every time. So see, do you know the derivative of 2? Yes, constant derivative 0. Do you know the derivative of second term? Minus 7 is a constant, remaining 1 by x. 1 by x derivative minus 1 by x square, you know that. Do you know the derivative next one? Most of them they don't know, but you know. We studied, right? 6 is a constant, right? 6 into remaining 1 by x square. 1 by x square derivative minus 2 by x cube, right? For that purpose, I asked you to take it as a formula so that you no need to waste time. Suppose if it is not x square, something else, x cube, x raised 4 and all, you take it to the numerator. You know how to do that. Suppose denominator is x cube, take it to the numerator, x raised to minus 3, then x raised in formula you have to apply, okay? So now you know the derivative dy by dx is 2, pure constant, 0, minus 7 into 1 by x derivative minus 1 by x square plus 6 into 1 by x square derivative minus 2 by x cube. That's all. So this is your answer. Just to simplify, minus minus plus 7 by x square plus into minus minus 6 2s are 12 by x cube. Hope you understood this. So we have done 23 sums. Now sum number 24. Okay, let's do few sums in log, right? I said log x derivative 1 by x, but I said that is for natural logarithm, right? Base must be e. If the base is not e, how to do that? So for that, you must know some of the properties in logarithm. Please listen here. So base changing rule, you have to study one thing, right? So log a to the base b. Suppose I want to introduce a letter c. What you can do? 2 times you write log. The letter what I want to introduce, you write cross. Suppose either here and here, or you write here and here. The letter which one I want to introduce. Suppose I want to introduce a letter C. And that C I can write here and here. Or you can write in the other places also. Or you can write it as log, 2 times log. That C can be written here and here. One place you write base, other one in the top you write. Okay. Now other two you can fill it. So see this A you write here. This B you write here, right? This is one method. Or this A, here there is no place, you write here A, and the base B you write here, right? So both are correct only. You can write in any one of the method. And how to simplify also you must know. Logarithm already you have studied. If you see the in between multiplication C, right? Leave that remaining log A to the base B. Here this cross you see C, leave it remaining log A to the base B. Both are correct only, right? So this is how you change it into the letter which one you want, you can change, right? So you can change the base like this. Now please listen here. Question number 24. Listen carefully. Suppose I am taking a question, log x to the base 10. Y equal to log x to the base 10. You can't write it as 1 by x, right? You can't write it as 1 by x. What do you do now? You rewrite it. So y equal to log of, you write 2 times log. I want to introduce a letter what? E, right? So I am writing E here and E here also. Then that x should be in the top, right? So x you write here and the base 10, here only have space, right? Like this you can write. So now listen here, now you can differentiate it. So dy by dx is, look at this, this is a multiplication only, no? This is a constant, pure constant. Can you write 0? No. Together a single term, right? This is like 5 into log x, something like this. If it is 5 plus, for 5 you put 0, right? So here you can't do like this. Log e to the base 10 you write as it is. Log e to the base 10 you write as it is. Now this you differentiate. This is natural logarithm, log x to the base e, or ln x, log x derivative 1 by x. So that 1 by x you write front, 1 by x into log e to the base 10. Further, if you want, you can simplify. There is another rule in logarithm. Log a to the base b. You can interchange these two. A and b you can interchange. What do? You put 1 by and you write log b to the base a. So this can be written as 1 by, if you want, x into. The log e to the base 10, you bring it down and you interchange log 10 to the base e, right? You can write like this also. I'll teach one more sum of the same type. Question number 25. I'll take one more question so you can understand better. Y equal to log 5 to the base x. 1 by y equal to log 5 to the base x. So you have to rewrite, right? So because the base is not e. So y equal to, you write 2 times log. The letter which you want to introduce, e, that you write e here and here. That x x, 5 is the base, right? So base you write 5 and that x you write here. Here it is multiplication only, right? So now you differentiate dy by dx. Here there is no x at all. There is no variable. Write it as it is, log e to the base 5 into log x base e only, log x derivative 1 by x. That's all. Hope you understood this one, right? So this answer can be written as 1 by x into log e to the base 5, or you can bring it down 1 by x into, you can interchange log 5 to the base e, right? So you can write like this also. So hope you understood this one, right? So almost all these we covered. Just I'm going to give you one question. So if you answer correctly, then I think I can go for another 10 to 15 minutes. Okay, we can go for another one more area I can teach you. Okay, so this is one to check how much you understood what I taught so far. Okay, so I'm going to write a question. Just go through, try to work it out and type your answer in the chat box. Okay, so y equal to x raised to 5 plus e power x. So while typing e power x, you can write like this. Okay, so e power x plus 5 raised to x plus e raised to 5 plus 5 square. Some of your things are such a lengthy question. No, it's very simple only. Just go through. Y equal to x raised to 5 plus e raised to x plus 5 raised to x plus e raised to 5 plus 5 square. Yes, try quickly. Most of the formula what we studied so far we used. No need to rewrite anything, right? Yes, already I'm getting some answers. What about other students? First one, x raised to 5, all of you know. Second one, e raised to x also, everyone knows. Then the remaining 3, do carefully. Dy by dx is, okay, some of you may find difficult to type because little in the answer, right? So next time I'll try to give some options also. So easily you can type A, B, C, D, right? Okay. So first one, some answers I'm getting. Okay, let me see whether it is correct or not. Listen, x raised to 5, sometimes you would have made some mistakes, so I'm going to clarify that now. Okay, so no problem. Please listen. X raised to 5, x raised to n type, right? So n into x raised to n minus 1, so the answer is what? 5x raised to 4. Second one, e raised to x derivative, e raised to x itself, e raised to x itself. 5 raised to x, 5 raised to x. So be very careful. And many students have made mistake in that one. 5 raised to x. So I taught no constant raised to function. A raised to x type. 5 raised to x is of which type? 5 raised to x is a raised to x type. What is the derivative of a raised to x? A raised to x log a. A raised to x log a. You have to be very careful, okay? So 5 raised to x derivative is what? 5 raised to x log 5. 5 raised to x log 5. What about e raised to 5 derivative? Pure constant. E is a constant. You are learning in physics, right? 2 point something. 5 is a constant. There is no variable at all. So its derivative 0. 5 square derivative, that also 0, right? 5 square 25 is a constant, 0. The last 2 terms 0, that's all. So this is your answer, okay? And some of the students partly correct only. So that's good. So I think I can go for another few more formula, right? Okay, please listen. That's good. Listen, how many formula we studied? 9 formula, in which most of the things are repetition only. So including that one is the 25 formula. So now I'm going to give another few formula. Those who have doubts, please note down. Formula number 10. Trigonometric formula. Some of you may find trigonometry a little tough, right? So, but trigonometry, I'll help you some other class, how to learn the formula very easily. So, trigonometric formula, sin x. So, just note down this, sin x derivative cos x, cos x derivative minus sin x, that is sum number 10, 11, then formula number 12. Tan x derivative. So first two you see sin x derivative cos x. Sin x derivative cos x. Cos x derivative minus sin x. Try to learn of itself. Sin x derivative cos x. Cos x derivative minus sin x. Tan x derivative secant square x. Tan x derivative secant square x. Cot x derivative minus cosecant square x. So sin x derivative cos x derivative minus sin x. Tan x derivative secant square x. Cot x derivative minus cosecant square x, and just two more formula. Secant x derivative, secant x derivative, secant x tan x, secant x derivative, secant x tan x, and 15th formula cosecant x. Cosecant x derivative minus cosecant x cot x. So go through these 6 formula what we study now, all trigonometric results, right? Trigonometric ratios. Sin x derivative cos x. Cos x derivative minus sin x. Tan x derivative secant square x. Cot x derivative minus cosecant. Secant square, cosecant square, right? One is plus, one is minus. Secant x derivative, secant x tan x. Secant x derivative, secant x tan x. Cosecant x derivative minus cosecant x cot x. Secant x tan x, cosecant x cot x. And 2 you compare and study, you can study very easily. Sin cos, sin x derivative cos x derivative minus sin x. Tan x derivative secant square x, cot x derivative minus cosecant square x. Secant x derivative secant x tan x, cosecant x derivative minus cosecant x cot x, right? And in some places plus, some places minus, very easily you would identify. Suppose if you find difficult where to put minus, if the ratio starts with C, it is minus. Is it not? Starting with C. Everywhere you have minus, right? Cos minus sin x, cot x minus cosecant x minus cosecant x cot x, right? Okay, so that you won't make mistake. So these formula you have to study. So here are nothing, direct question only they can ask. Suppose my question is, so we did 26 questions. Now we continue, 26, question number 27. Suppose y is equal to 2 plus sin x minus log x plus e raised to x. Just like this, these type questions only. So dy by dx equal to just a revision, right? See, 2 is a constant, 0. Sin x derivative cos x minus log x. Nothing means it is what? Natural log of the base e. Log x derivative 1 by x plus e raised to x derivative what? E raised to x itself. Suppose the base is not given, you take it as e only, right? So these formula you study. So next class I will be teaching sin square x and all, how to differentiate. At that time it will be useful to you. Okay. So now this 15 formula, that just you take it, and just I am going to give just 2 more formula. Based on that few sums we do and we stop today's class. Okay. Now formula number 16. That's a very important one called product rule. Product rule. Okay. So please look at this one. I'll tell you what is that rule for. But before that, when to use this formula and how to use, both you need. Okay. Listen here, product rule, you know, the name itself, it is there, right? Product. Product of 2 functions. It should be a function into another function. Function means there should be some variable, right? A function into function. Suppose a function into a constant, don't use product rule. For example, 5 into log x, don't apply product rule because this is a function, this is a constant, right? You can differentiate directly. Suppose this is y equal to 5 log x, dy by dx is equal to 5, you write as it is, log x derivative 1 by x, so the answer is 5 by x, that's all. That is constant into function. Product rule when to use, you know, a function into function. For example, x into log x or sin x into e raised to x. Because this is a function in between multiplication. Here apply product rule. So that you must be very clear. A function into another function, we apply product rule. Okay, so now what is product rule? Listen here. Suppose derivative of uv. U is a function, v is another function. A function into function, u into v. The answer is very simple method I'll give you. U v dash plus v u dash. Okay, the dash gives the derivative. That is the denotes derivative. So derivative of uv, a product of two functions. Two function கொடுத்திருக்காங்க u into v. U is a function of x, v லையும் function of x தான். Then you have to apply product rule. எப்படி product rule apply பண்றீங்க? Write the first one as it is. U into second differentiate பண்ணணும். Second என்னது? V. V க்கு derivative v dash. First into derivative second plus second into derivative first. That's all. Suppose if they give three functions. Okay, I'll give a small sum for this. 27 we finished now. Yes, question number 28. Suppose the question is y equal to x log x. Y equal to x log x. Here you have to apply product rule. Why? Because x is a function, log x is a function in between multiplication, x into log x. Suppose the question is x plus log x, you do directly. Two separate terms, right? X derivative 1, log x derivative 1 by x. But here you cannot do like that. Don't say it is x in x derivative 1 into log x derivative 1 by x. No, it's wrong. Okay. So here you have to apply product rule. This is our u and this is our v. So you apply the formula derivative of uv. Derivative of uv. What's the formula derivative of uv? uv dash plus v u dash. uv dash plus v u dash. So look here, dy by dx is u into, this is u, x into, differentiate the second one. Differentiate the second one, log x derivative 1 by x, log x derivative 1 by x, plus second into, what is the second one? Log x into derivative of first, x derivative 1. X derivative 1. So first into, write the first one, x into, differentiate the second one, log x derivative 1 by x, plus second into, that is log x into derivative of the first, x derivative 1. That's all. So here x and x cancel. So the answer is 1 plus log x. But you see, if you don't know the log x derivative, you cannot do this one. You may know product rule. That is the reason you start from the basics. Okay. Look, I'll give another question. Question number 29. Suppose the question is y equal to e raised to x sin x. Now we are doing product rule, so your mind will think only that product rule, right? But next class I'll be combine here and there. So at that time you know, you can understand better, okay? So please listen here again, product rule, because e raised to x is a function, sin x is a function in between multiplication. So we have to apply product rule, right? Because a function into function varradhanaala product rule apply pandrom. So you write product rule. Derivative of uv, what is product rule? U v dash plus v u dash. You learn like this. First into differentiate the second plus second into differentiate the first. Even you can change the order because in between plus one, you know, எந்த ஆர்டர்ல வேணா நீங்க மாத்தி எழுதலாம். But better you write like this. So dy by dx is first into, what's the first one? E raised to x, first into, differentiate the second. Second differentiate பண்ணுங்க. What is the second one? Sin x. Sin x க்கு differentiation cos x. Cos x differentiation minus sin x, right? Now itself you learn sin x derivative cos x derivative minus sin x. So here sin x derivative cos x. So first into derivative of second plus second into, இப்போ நம்ம second அப்படியே எழுதணும். What is second one? Sin x into derivative first e raised to x derivative e raised to x itself. Okay. So now if you can simplify, common what you have? E raised to x is common. So remaining cos x plus sin x. Cos x plus sin x, or you say sin x plus cos x. Okay. Okay, I think that part you are thorough. I'll give, so product rule, there is one more thing I'll give you. Derivative of u v w. What is this? Product of two functions we studied, but here product of three functions. Please listen, very simple method I'll teach you how to remember very easily. UVW plus UVW plus UVW. Write 3 times UVW. Every time you put dash for one letter. For the first one you put dash, U dash. Second time V dash. Third time W dash. That's all. So 2 terms you write as it is and the other one you differentiate. Like that you do for all the 3 terms, right? So first and second, we are differentiating the first one. Other 2 you write as it is. Now second term you differentiate, other 2 you write as it is. Then third one you differentiate, other 2 you write as it is. Okay. So this is how you have to differentiate this one. Okay, just I'll give a question for that. Question number 30. Suppose the question is y equal to x into sin x into cos x. So in between no plus, no minus, right? X into sin x into cos x. So product of three functions here. This is a function, this is a function, this is a function. This is of the type u, v, w, right? So you know the formula derivative of u, v, w is easy method. You write 3 times u, v, w plus u, v, w plus u, v, w, right? So every time you put dash for any one term. Okay, so first if suppose w dash, then here v dash, here u dash. Okay, any order because it is plus only, no problem. So dy by dx is, now please listen, these are all just revision for you. You learned the one formula, but what we studied so far, x derivative 1, sin x derivative cos x derivative minus sin x, that only we are going to apply, right? So first and second I am writing as it is, x into sin x. Third one you differentiate, cos x derivative minus sin x. Second time, first one you write as it is. Second one you differentiate sin x derivative cos x. Third one no change, write as it is, cos x only. Plus the last one. First one you differentiate x derivative 1. Other two write as it is, sin x into cos x. You differentiate one at a time, right? So then if you can, you simplify x into minus is there, sin square x plus x into cos square x plus sin x cos x. Okay, so hope you understood this one. Just I am going to teach you only one more formula, and with that we are going to stop today. Just another 5 minutes. Okay, now formula number we studied, product rule we studied, formula number 16 we studied. Now the 17th formula. So now you know almost 80% we finished, right? Because I said maximum 25 formula only. Now we are in the 17th formula, okay? So quotient rule. So the next class will be very, very important one. It's continuation only. So if you are thorough with this one, next class will be a very, very interesting one and it will be a very, very useful one, okay? So now product rule already we studied. When to use product rule? A function into function, right? Product rule, a function into another function. So you can guess when to use quotient rule, right? A function by another function, a function divided by another function. Here we have to use quotient rule. Just a moment. Okay, formula number 17, quotient rule. Listen here. So when to use this? A function by another function. A function by another function is very important one. Please listen, students. Derivative of u by v. U is a function, v is a function. Product rule is u into v. Quotient rule is u by v. Just I'm going to teach the formula. Listen here, and here some interesting sums we are going to do. Listen. The formula first you learn. Denominator, you write denominator square. Denominator is v, you write what? V square. Start with denominator. Start with denominator. That is v into u dash minus u into v dash. Here the order is important. Product rule I said even you can change the order because in between plus. But here it is minus. So the order is important. Please listen one more time. The formula derivative of u by v. Derivative of u by v is denominator you write v square. Denominator you write what? V square. Whatever we have the denominator, here v, you write what? V square. Start with the denominator. Start with the denominator. First you write v. V into u dash minus what? U into v dash. Okay, so using this formula, so we do a lot of sums and this continuation we will do in the next class. Okay, so please listen carefully. So hope you understand the sums what I taught today, and type your suggestions and your feedback in the chat box. Okay, chat box, you can type that one, so it will help us to help you in a better way. Okay, so next class what I'm going to teach, next class we are going to do quotient rule. So this quotient rule, just to explain what is the rule only. So using that we are going to do sums. Some questions are there, it looks like quotient rule, but we won't apply quotient rule. Direct simple methods are there. Okay, that I'll be teaching you in the next class. Then we study some of the very important differentiations, logarithmic differentiation, parametric form, implicit functions. All these I'm going to teach you in the next session. And in the third class, the advanced level, that is the higher derivative, higher order derivative, 2 times differentiation, 3 times differentiation, and the sums for your JEE examination, all these things will be in the third class. Okay, you send your doubts about today's class if you have any doubts, and your expectations, what you expect from us, you can send it through our website. Okay, through our website you can send it, and for our regular updates, you can visit our website and subscribe our YouTube channel so that you'll get the notifications. And I hope you enjoyed this session. So we'll meet you soon through the next video class. Till then, goodbye from Think Excellent team. God bless you.